Hey, hi, hello guys, welcome back to Code with Nani channel. Today we're going to discuss about the lead code problem of the day, design a number container system. So just read the question. Um, Implement the number container class, so in which we have two functions called void chain and infined functions. So void change, like it has a two parameters, index and as well as the number. So fill the container at index with the particular number. If there is an already a number at that index, we need to replace it. So simply like we'll erase the old number and just assign a new number. And int find number. So for this function need to return the smallest index for that given number. If there is no index regarding to that particular number, we just need to return the -1 as our answer. So I'll just explain you through my Microsoft notebook so that you get a clarity about everything. So yeah, we need to design it two functions, void chain as well as infine. So here, as you look in the question, the constraints for these questions are um, constraints or n less than or equal to capital N temp of 5. So if you design any function in O of n time, like if you design any function in O of n time, which means so each each call we are making into n time. So for n calls, n into n, which is n square, that is like 10 power 5 into 10 power 5, which gives 10 power 10 more than 1 second, as 10 power 8 equal to 1 second. It is a 10 power 10 operation which gives you TLA. So we need to design the functions in such a way that it should be within the bounds of the constraint. So which means like we need to design the function in a of one time, because if you design it of one time, or you can even do it in a of log n time. So how do we do this? So the real intuition. So what is this change function is doing? It takes index and the number as the parameter. So what we need to do is we need to check whether this particular index has been assigned to any another number before. So if index has been assigned to previous number, we'll do some particular condition. If it is done, if it is assigned, so we need to reduce that. We need to remove that index from that particular number. Suppose there is another number that has been mapped to this particular index, then we need to erase of this index from that number. Okay, and we need to redistribute, we need to like assign this index to that particular number. Okay, something like that. And what is this find function is doing? Just take the num as the parameter, and we need to return the smallest index of all the indexes. So if you carefully observe, we get a sense that for a number, we have a set of indexes, and we need to retrieve the smallest index from this set of indexes. So how can you achieve that? So by this sense, we can directly say that you can use a map which consists of, which can be mapped a key as a number, and we can have a set of index, but we need the smallest index, so which can hold that order of the elements. So set is the best data structure that can hold the order of the index. So we can just use the set and get the begin as a iterator to give the smallest index that is present in this set of the particular number. So we can directly use the set, right? Set and get a number. Suppose using this, you can directly retrieve the answer for the find function. So if we have a param as find of number, we can directly give return star of emp of number dot begin, which gives the starting value of that particular number. If that particular number is not present in the map, we can directly return -1. So this is O of n time, O of 1 time, sorry. This can be retrieved using a O of 1 time. So we have successfully build this find function. So how do we build that change function? Change function. So now our map of int comma set, okay, so it consists of number to the set of indexes, right? So it is a key value with the number and value as a set of indexes. So whenever a new index came, we don't know exactly like whether it is been visited before or is it coming as a new thing. Suppose if it is mapped with some other another number as previous, so how do we get that value? Because we are using a key as the number. We don't know. We are not using an index. If we are using an index, we know like for this index, this is a number that has been mapped before, but we are using a key as a number, so we cannot directly retrieve like this index has been mapped to that particular number. So for that sake we are using another map which can hold this index as the key value and number as the value. Suppose if it has been previously mapped, so we can directly find through the map of index, so we can get the old number. Using this old number, we can directly make a changes on the main map. So we can directly erase for that. We can directly retrieve this map of a old number and can directly erase that index from that set of indexes. So cool. What we can do is we'll have another map which can hold int comma int, which is a number. Sorry. So which is indexes comma number. So whenever this indexes has been previously visited, we can directly retrieve the old number and can directly make changes in the main map. So I'll just go through you guys so you'll get everything around it and you'll get a clarity around the question. So we need to declare the two maps, right? On order, or you can use order as well. Let's just use order map. One is int, another is for set. Okay, mp. So what it does is it maps a number with the set of indexes. There can be n set of indexes as well. Another map to check whether it has been previously visited with previously mapped with some other number or not. mp1. So it is a index to the number. So just design the find function. Suppose if mp.count of number, which means is this number exists in the map or not. If if that number is exists in the map, as well as that set value, like for this number, if the set value, which means that mapped indexes is greater than 0, we can directly retrieve the smallest index. If that is 0, then we don't have any other index that is mapped to that particular number. We can directly retrieve -1. So mp of number dot empty, it can check the case whether it is a 0 or not. If in that case, if it is not empty, we can directly return. So if that value is present in the map as well as its set value is not empty, we can directly return the value. Can directly return the starting value, which means like set holds in a sorted order, so begin value will be the smallest value on that set order. So I can directly return begin. If it is not, then just return -1. Okay, cool. So that is how like we design the find function with the O of 1 time, and we'll get back to the change function. So in the change function, there might be two cases. The first case is we don't find this index previous. In that case, we can directly push it into the map, as well as we can directly push it into the index 2 number array. So that's what we'll do. mp of this particular number dot insert of index. We directly pushed into the main index, as well as we directly pushed mp of 1 of index with that particular number. So in other case, we might be having this index has been repeated previously, which means that mp1 of index p1 of index mp dot 1 of round of find of this particular index is not equal to mp dot n, which means that it has been repeated before, right? In that case, we need to remove the index of that old number, and we need to add it to the new number. So how do we get old number? For that sake, we have a mp1 which holds the previous number through the index. So int old num, and the old num is equal to mp1 of with the particular index. So we can able to get the old number using this. What we need to do, we need to reduce this particular index on that old number on your main map. So mp of empty dot mp of old number dot arrays of this particular index, right? And what else we need to do? If that particular number set has been become 0, we need to remove that it from the map, because we don't require it anymore, because there is no other index to this particular number, so we can directly remove it. So if mp of old num dot empty, which means there is no other element left on the set, we can directly emp dot arrays of old num. Okay, cool. And if all the changes has been made, and we can directly map it to the new number, because these two conditions are required for the uh, previous for the new number as well, even if the index has been repeated. So we can directly, so old number set has been removed, and it is mapped to the new number. If there is no old number, we don't go through this if statement, and we can directly push it into the map. So that's how we build this change function as well in a WoW one time. Let's just run the code. Yeah, I did. Just submit it. Voila, submitted. And if you like the video, do like my channel, subscribe to my channel, and hit that bell icon. That's it for today video, guys. See you tomorrow. Tata, bye bye.